Okay, paralytic sycophants, carrion eaters, servile imitators, degenerate rabble, playboy scatterbrains, conceited dandies. You all are very welcome to the realm of knowledge of discrete mathematics. Let no one without hunger of learning enter here. Amen. Let's go for sets then. What is the name list, please? Here, okay. Who's going to be my scribe today? Jesus Perez. Yes. You have to take notes of the English corner, please. You have my email address. Yeah? No? So, there is a little review about sets, functions, and relations. Well, relations is new stuff. But yes, a little short, brief review about sets and functions. You are supposed to know that already. But just in case, we will cover it again just for completeness. Right? So, a few definitions here. Can anybody tell me what a set is? No? Okay. It's not because you are afraid to speak up? Or because you don't know? We don't know. It's not a series of numbers because I can't have sets made of any kind of letters or another sets. It's just an unordered collection of objects. Okay, first word, we open the English corner up. Order. In my pronunciation, I pronounce, in American pronunciation, you pronounce that R here. In British English, you say order. It's a little bit snobbier, but that's for you to know. Okay, so here I'm using the term object intuitively, right? So there is a formal definition of object, especially of objects that can form part of a set. But for now, that's enough for our purposes. So. These objects are called elements. Or members. Our book uses both. Okay. There are two ways of defining objects. The first one is called enumeration. And, well, it just consists of enumerate the elements. Like I say 1, 2, 3, 4, 9, 0. That is my set A. Or this is the set of English vowels as symbols, as letters, not as sounds. Right? The other way is called set builder. With a long E, builder. What's that? Describe the set by means of a property. Like, for example, this set here, I can describe it as those elements in capital N, the set of natural numbers, such that 0 is less or equal than x, x is less or equal than 9. That's another way. Another example here. Oh, sorry. That was I'm asleep. Sometimes I don't write the phonetics because it is vocabulary, and I'm expecting you to look it up in the dictionary and learning. Sleep means lapsus, error, fallo. I just wrote the Spanish name for the sine function. Sorry about that. So there is one good question that it could go to the exam. Suppose that you are given this set, and you are this set is described by a property, sine of x equals 0, and I want that set described by enumeration. Then the answer will be
zero.
I heard 0. That's it?
No.
Okay, this, how do you pronounce this in English? Pi. That's pi. Pi. So 0 is the wrong answer. 0 is one element of this set, but by saying 0, that's clearly quite incomplete. So the full answer is pi, etc. But minus pi, because I can go the other way around. Okay. More. Yeah, some important sets. This is notation basically. This is just review. If you get bored, just let me know. This is 0, 1, 2, 3, blah, blah, infinity. 0 is a natural number. Then we have the set of integers, another word here. I need more space. Everything was committed. I've heard integer, and believe me, I swear, I didn't have a clue of what the guy was saying. Integer doesn't mean anything to an English person. Integer, that. Okay, so the set of rational numbers. And or the set of real numbers. Okay, nothing to worry about so far. So far so good. First, slightly difficult definition. Set equality. Set equality. So sometimes you see these. A and B are sets, and we say A equals B, and the definition of this that's the definition. So the definition comprises two implications. Every element in A must be an element in B, and every element in B must be an element in A. There have been some questions about set equality in the last few exams. So sometimes not that. And set inclusion which is notated by that, notated. Notated. Every element in A must be an element of B if A is including B. empty set. That's trivial. That's the set composed of no elements. So this is true, right? Because the empty set has no elements and is considered to be a subset of any set. That's a convention, if you like. And also, every set is a subset of itself, right? So there are two trivial subsets of any set, the empty set and itself. Every other subset is called a proper subset. Right? Subset is a nice word. We should write it down. Okay. And finally, do you have any questions about the magic effect that I performed yesterday? I'm gonna give you a week to discover the mathematical principle behind it. You have to give me like, I don't know, 1 page, 2 page report where you describe and analyze the magic effect. If you come up with a solution, great. Tell me when it works, when it doesn't. Oh, it doesn't. Another word that everybody says, wrongly. Okay, I'm going to pronounce it, and you will tell me what should I put here. Dal. I heard something nice here, although in Spanish. Okay, then at the end of the phonetics, you have the names of the phonetic symbol. You should learn them by heart, right? Yeah, somebody said turn V. That's the name. And then I have to say what? I have to write down what? Dal. Yeah, Z. The voice. Tomorrow I'll cover voiced. Sonoro. Voiced. So it's das. Das. As such, is this word. It sounds like this word in English, which is something else. Does. So I was saying you have to tell me when it works and when it doesn't. And there is 0.15 points of the final grade at stake. Stake, you know stake?
En juego.
En juego, yeah. Stake. As a fake expression. You're free to go. See you tomorrow.